From shape memory metal to volatile powders to programmable wood to hot ice, the planet is packed with all kinds of wildly unusual materials and substances. The molecular structure of our world is a billion times more bizarre than you may have ever imagined. For today's video, we're going to take a look at 15 of the weirdest known materials that completely defy logic. Let's start off with number 15, metallic hydrogen. Metallic hydrogen is one of the rarest, most exotic phases of matter ever studied. Normally, hydrogen exists as a gas, simple, invisible, and light. But under unimaginable pressure, it's theorized to transform into a metallic solid that conducts electricity better than nearly any known material. The concept originated in 1935, when physicists Eugene and Hilliard Bell proposed that extreme compression would cause hydrogen's electrons to delocalize, acting like those in metal. Earth can't naturally generate those pressures, but gas giants like Jupiter and Saturn can. Their core conditions may turn hydrogen metallic, fueling their huge magnetic fields. In 2017, Harvard researchers announced they had created metallic hydrogen at around 495 gigapascals, but the sample vanished and replication failed. Still, scientists think it may be a room-temperature superconductor or an energy-dense rocket fuel. It's a material that redefines the potential of the universe's most basic element, from the lightest gas to a glowing metallic state under extreme force. Number 14, superfluid helium. Helium is best known for inflating balloons, but under extreme conditions, it behaves like no other substance. When cooled to nearly absolute zero, helium transforms into a superfluid, a state where it flows with zero viscosity. In this form, it does things that defy normal fluid behavior. It climbs container walls, spreads as a thin film, and slips through microscopic pores that block other liquids. It also transfers heat more efficiently than copper, since thermal energy moves in waves through the superfluid. There are two isotopes. Helium-4 becomes superfluid at 2.17 Kelvin, while helium-3 does it below 0.0025 Kelvin. This phenomenon, rooted in quantum mechanics, was first observed in the 1930s by Kapitsa, Allen, and Missener. Kapitsa received the 1978 Nobel Prize for his work. Although it's impractical for daily use due to extreme cooling requirements, superfluid helium plays a supercritical role in physics research. Number 13, self-healing concrete. Concrete is the world's most used construction material, forming the skeleton of cities and infrastructure. But it's prone to cracking, and those cracks let in water and oxygen, leading to rusted rebar and weakened structures. To fix this flaw, researchers created self-healing concrete, one of the strangest, most practical innovations of recent years. The concept is surprisingly simple. Mix in special agents like bacteria or chemical capsules that react when damage occurs. One method uses bacillus bacteria and calcium lactate. When cracks form and water enters, the spores activate, multiply, and deposit calcium carbonate, sealing the gaps. Other designs use embedded capsules filled with epoxy-like substances that release and harden when stress breaks them. The concrete literally repairs itself. Dutch scientists pioneered this tech, and commercial versions appeared in 2015. Although still expensive, the benefits are huge. And now, here's the fun fact. It was founded millennia ago, and it's called ancient Roman concrete. Number 12, Vantablack. Vantablack is one of the darkest man-made substances ever built, and it's captured the attention of scientists, artists, and the public since its inception. The name stands for vertically aligned nanotube arrays, which hints at why it's so unusual. Vantablack is made from a dense forest of vertically aligned carbon nanotubes. When light hits the surface, instead of reflecting, it gets trapped within this structure, bouncing around until it's completely absorbed. It reflects almost no visible light, absorbing up to 99.965%, which causes any three-dimensional object coated in it to appear as a flat, detailless void. It's visually disturbing, as our perception depends on reflected light to define depth and texture. Created in 2014 by Surrey Nanosystems in the UK, Vanta Black was designed for scientific and aerospace use. Artist Anish Kapoor's exclusive rights to it stirred controversy. Despite rivals creating alternatives, Vanta Black's extreme darkness and delicate application process keep it mostly restricted to research and optics, and it still unsettles the senses. Number 11. Graphene. Graphene is a one-atom-thick sheet of carbon arranged in a two-dimensional honeycomb lattice, and it's one of the most amazing materials ever found. Though carbon is among Earth's most abundant elements, the structure of graphene gives it unmatched properties. It's incredibly strong, extremely light, and electrically superior. In 2004, researchers at the University of Manchester isolated it using ordinary tape to peel layers from graphite until only a single layer remained. Their discovery earned the 2010 Nobel Prize in Physics and sparked massive global research. It boasts a tensile strength of around 130 gigapascals, over 100 times stronger than steel, while weighing nothing. A sheet the size of a football field would weigh under a gram. It conducts electricity better than copper and has potential applications in flexible electronics, ultra-fast transistors, batteries, sensors, and water filters. Producing large, high-quality sheets remains a challenge. Still, graphene's weirdness lies in how such an impossibly thin. Number 10. Aerogel. Aerogel is often called the world's lightest solid, and for good reason. Nicknamed solid air or frozen smoke, it's a synthetic, porous substance created by replacing the liquid in a gel with gas. What remains is a fragile framework that's over 99% empty space, yet it holds together as a solid. It was first made in 1931 by Samuel Kistler, who won a bet claiming he could remove liquid from jelly without collapse. His method worked, and the result was like nothing seen before. Though it looks brittle and ghostly, aerogel is deceptively strong. A small piece can support a brick, and its low density ranges between 0.001 and 0.5 grams per cubic centimeter, lighter than air. Its thermal insulation is exceptional, which is why NASA uses it on Mars rovers and space missions. Some versions are transparent. Others glow faintly blue due to the way light scatters through its nanostructure. Despite being fragile, researchers continue refining aerogel uses. Number 9. Starlight. Starlight is among the most mysterious materials ever introduced to the public. Invented in the 1980s by Maurice Ward, a British hairdresser and amateur chemist, starlight stunned audiences with its incredible heat resistance. Demonstrations showed it withstanding extreme flames and even laser beams without transmitting heat to underlying surfaces. Ward claimed it could resist temperatures up to 10,000 degrees Celsius, far exceeding most known materials. In one famous TV demo, he coated an egg in starlight, exposed it to a blowtorch for several minutes, and cracked it open, completely uncooked inside. Despite widespread attention, Ward never revealed the composition, fearing it would be stolen or misused. He passed away in 2011, and the exact formula died with him. Critics questioned the lack of independent testing, but official interest and public demonstrations gave the claims credibility. Whether it was truly revolutionary or simply overhyped, starlight remains a strange legend in material science. Now, let's move to Number 8. Liquid metal. Liquid metal, officially known as bulk metallic glass, is a class of materials that blends the strength of metals with the structure of glass. Unlike typical metals with organized crystalline structures, bulk metallic glass has atoms arranged randomly like glass or plastic. This gives it an unusual set of properties. Tough like metal, yet elastic and resistant to wear. Traditional metals deform under pressure, and glass shatters when stressed. Liquid metal resists both, returning to its shape without breaking. First created in the 1960s, it gained momentum in the 2000s thanks to research at Caltech and firms like Liquid Metal Technologies. Apple even licensed it for small components. What makes it strange is how it behaves. It can be molded like plastic, yet holds the durability of steel. It's made from alloys like zirconium, titanium, copper, and nickel, and rapidly cooled to prevent crystals from forming. Though costly to scale, it shows promise in medicine, sports, and aerospace, anywhere strength, precision, and flexibility are needed. Number 7. Teflon. Teflon, chemically known as polytetrafluoroethylene, is one of the slipperiest, most chemically resistant materials ever invented. Though widely known for non-stick cookware, its discovery in 1938 was accidental. Chemist Roy Plunkett, working at DuPont, was experimenting with refrigerants when a gas inside a pressurized cylinder turned into a waxy solid. That substance turned out to be Teflon. Its structure features carbon atoms shielded by fluorine, one of the strongest chemical bonds in existence, making it nearly immune to chemical reactions. Nothing sticks to it. It's heat-resistant, doesn't absorb water, and its coefficient of friction is among the lowest ever recorded. Beyond pans, PTFE is used in electronics, aerospace, wires, and even military gear. It doesn't conduct electricity and withstands extreme environments. Despite controversy over its production, its utility remains unmatched. Teflon's weirdness lies in its contradictions. Number 6. Terphenol D. Terphenol D is a bizarre alloy made from terbium, dysprosium, and iron that behaves in ways that feel almost alien. Its defining feature is magnetostriction. It physically changes shape when exposed to a magnetic field. The effect is tiny, just micrometers, but powerful enough for serious applications. Developed at the U.S. Naval Ordnance Lab in the 1970s and 80s, its name combines its components: Ter for terbium, Fe for iron, NOL for Naval Ordnance Lab, and D for dysprosium. Researchers were searching for materials that could efficiently convert energy between magnetic and mechanical forms, and what they found was something entirely different from ordinary metals. Terphenol D now powers sonar systems, actuators, and precision vibration control tech. It can transform magnetic signals into mechanical motion and vice versa, with virtually no wear. Though expensive due to rare earth elements, it remains unmatched. Number 5. Gallium. Gallium is a shiny silver-colored metal that seems ordinary until it melts in your hand. With a melting point just under 30 degrees Celsius, gallium transforms from solid to liquid from simple body heat alone. That's deeply unsettling, because metals aren't supposed to act this way. Gallium was discovered in 1875 by French chemist Paul-Émile Lecoq de Bois-Baudran. Its name comes from Gallia, the Latin word for France. Its existence had been predicted earlier by Dmitry Mendeleev, who left a blank for Eka aluminum in the periodic table, which gallium perfectly filled. Beyond its strange melting behavior, it remains liquid across a huge range, from room temperature up to 2,200 degrees Celsius before boiling. It's mainly extracted as a byproduct of aluminum and zinc refining. It is essential for modern tech, powering semiconductors, LEDs, solar panels, and laser diodes. Gallium isn't toxic like mercury, but its weirdness lies in how it breaks every rule about metals. Number 4. Amorphous ice. When most people think of ice, they picture the classic crystal form, neat hexagonal structures built from water molecules. Amorphous ice shatters that idea. Instead of lining up in repeating patterns, its molecules are locked in a chaotic, glass-like arrangement. This form of solid water only forms under extreme conditions, like when vapor freezes instantly at -150 degrees Celsius, or when pressure crushes standard ice into disorder. You won't find it on Earth's surface, but in space. It's everywhere. Telescopes have spotted amorphous ice on comets, icy moons, and cosmic dust. It's thought to be the most common type of frozen water in the universe. Scientists also study it to understand water's bizarre behavior, why it expands when it freezes, or why it defies so many normal chemical rules. Some even believe amorphous ice could reveal a hidden, second liquid state of water. It looks like cloudy glass, but it holds secrets about the cosmos and maybe even life itself. Number 3. Metallic glass foam. Metallic foams blend the strength of metal with the lightness of sponge-like structures. But metallic glass foams take that to another level. They're created by taking bulk metallic glass, already strange for its non-crystalline atomic layout, and shaping it into a porous foam. This creates a material that's lightweight, yet tough and impact-resistant. The empty pockets inside let it absorb energy, while the amorphous structure makes it stronger than many steels. When compressed, it deforms predictably, without shattering. That's why it's being explored for crash protection, armor, and even medical implants. Some researchers use gas to blow bubbles into molten alloy before flash cooling it, similar to candy making, preserving the glassy structure. Though still experimental and expensive, metallic glass foam opens doors in aerospace and advanced safety tech. It's strange because it shatters expectations. Metal that's porous yet strong, light enough to lift easily, yet able to resist crushing force. An odd blend that shouldn't exist, but does. Number 2. Lutetium aluminum garnet. LuAg, or lutetium aluminum garnet, is one of the strangest and most quietly powerful synthetic crystals in science. It looks like a plain, transparent stone, but its capabilities are extraordinary. Formed by combining lutetium, a rare earth element, with aluminum oxide in a garnet structure, LuAg is dense, stable, and capable of converting high-energy radiation into visible light. That makes it ideal for PET scans, gamma-ray detectors, and advanced laser systems. Though lutetium is hard to extract and expensive, its weight and atomic structure make LuAg uniquely durable. It doesn't break down under radiation like other crystals and performs in extreme environments. When doped with cerium, it glows under radiation, becoming a scintillator that helps create detailed medical images. What makes LuAg strange is how it quietly breaks every rule. A crystal that's invisible yet heavy, stable yet reactive. You've probably never seen it, but in hospitals and labs, LuAg is silently doing incredible work. Number 1. Transparent aluminum. Transparent aluminum, officially aluminum oxynitride, or ALON, sounds like sci-fi, and it kind of is. Popularized by the 1986 film Star Trek IV. The voyage home, it became real just years later. ALON is a ceramic made from aluminum, oxygen, and nitrogen, forming a transparent, glass-like material that's far tougher than it looks. Developed by Raytheon in the 1980s, ALON can stop bullets, resist shock, and outperform traditional bulletproof glass. It's lighter, thinner, and more durable than laminated glass, making it ideal for armored vehicles, aircraft, and protective enclosures. It also transmits light across UV, visible, and infrared wavelengths, which makes it useful for military optics and multispectral sensors. Producing ALON is expensive and involves high-temperature processing and precision polishing, but prices are gradually dropping. It may soon appear in consumer electronics like phones. What makes it strange is how it blurs fiction and reality. If you've enjoyed this video, be sure to like, share, and subscribe. Thanks for joining us on this journey, and we'll see you in the next one.